everyone, it's James, and today I'm here to talk to you about Winnebago's new Power Max system. Like, what is it? What does it do? Do you want it? That kind of thing. And I suppose if you want the Reader's Digest version of the video, it's Winnebago's next generation power architecture. Cool stuff, and yes. Anyway, but we're going to talk about Winnebago's Power Max, and specifically, I'm going to lean kind of heavily into what we saw in the new Winnebago Revel. Now, we've done a review of that. I got to put my hands on it at the Tampa RV show. So I'm going to lean into that. But this is going to start showing up in other Winnebago coaches. So it is something you need to kind of wrap your head around. And it'll be Power Max or maybe other flavors of it. But the architecture is going to be kind of similar. Now, this video is brought to you by our friends at Winnebago. But in order to show you this system or the architecture, I thought it might be interesting to compare it to something that I am very, very familiar with. And that is our own 20K system as installed in number one. Now that's a 20,000 watt hour lithium battery system that I installed myself. I did it about 3 years ago, but I still think it's pretty darn cool and it's highly capable. And so by comparing the two, it'll kind of help you learn a little bit more about Power Max. So let's get going. So here we are in number one, and the first thing you probably need to know about Winnebago's Power Max is that it is a 48 volt architecture. Now, why is that? Because here in number one, this system was built on a 12 volt architecture. But the writing is kind of on the wall. That's sort of the way things are going, at least, you know, in terms of Winnebago coaches. I can guarantee you'll see more 48 volt coaches coming out in the future. And this really makes a lot of sense, especially for like a motorhome or something that might be driven and charged by an alternator, because the why comes down to a matter of charge rate. So electrically, if you want to move power, it's volts times amps. Watts equals volts times amps, right? You just multiply them together. So if you want to move power from A to B and you want to move a lot of power in a hurry, you need to either move a lot of volts or a lot of amps. Like if you wanted to move 400 watts, you could do 400 amps at 1 volt or 400 volts at 1 amp. It's the same amount of watts, but different characteristics of how you move the power around. But here's the thing. It's pretty easy to handle high voltage, but amperage is constrained by the size of the pipe. Remember, amperage is like flow rate, so there's only so much water you can get through a straw. I don't care what the pressure is, there's only so much water going to come through a straw. So when you want to get high charge rates, you kind of need larger cabling, like this. This is a cable that I used when I installed, the cable run from our own second alternator, and it's up here. Now, that alternator can charge our RV at about 3,500 watts is the most I've seen. And there's a decent amount of copper in there, right? So 3,500 watts in a 12 volt system, because we have to move we're getting up to close to 300 amps, right? So we need kind of a big cable. Now, 48 volts allows charging like over 7,000 watts. So if I were to double that, I would need just a cable like as thick around as my arm to do that in a 12 volt system. It would just be unmanageable to get something much, much bigger than this, because smaller cables, you wind up with more losses, you wind up, the cables heat up. I mean, all sorts of bad stuff happens if you don't use a large enough cable. So that's kind of the main driver behind the 48 volt switch, is to get higher charging rates so you can charge up in a shorter period of time. And there we go. So let's talk batteries. And this is number one's battery bank here. So now when we're talking about the 20K project, as you see here in Winnebago's Power Max, there's a lot of ways the batteries are the same. They're both Lithionics batteries. They are both lithium iron phosphate batteries. It's kind of the safest lithium chemistry you can get. And they both offer CAN-based charging. So that's charging based on data. You see all these extra cables that I've got kind of daisy chained on all 5 of the batteries here? That is actually sending data to a charge controller that will actually regulate the charge so that the batteries get exactly the charge from the alternator that they're asking for. That's great. That's how they're the same. Now let's talk differences. Obviously, we've gone over this. This is a 12 volt architecture. Winnebago's Power Max is 48 volt. I've got 5 batteries in parallel. They've got 48 volt batteries. Now, capacity, I've got 20,000 watt hours here. Winnebago's Power Max in the Revel, you can get either 7,500 watt hours or 15,000 watt hours. So I've got a bit of an edge there. But one of the big differences is that I have got internal BMSs in each of these batteries. So I've got 5 different BMS modules, and you'll see I've got 5 different power buttons to turn them on, and 5 different data streams all aggregated going to the charge controller. Individual BMSs per battery, whereas in Winnebago's PowerMax, they have an external BMS. That means it's a single point of information for all the battery modules. It's one BMS managing all the batteries. That's great. There's a single place even to turn on and off all the batteries. I rarely mess with these buttons, but if I wanted to turn them off, I'd have to hit 5 of them. So there's that. And then the other thing about the external BMS is it's got physically larger contactors. It can withstand a higher rate of charge for a longer period of time than any one of these individual BMSs in my 12-volt system here does. Now, granted, I've split the load because I'm in parallel over 5 different batteries, but you should know that the external BMS does have larger contactors, so you can sustain higher charge and discharge rates for longer. So the next thing we need to talk about with the PowerMax architecture is the Power Hub Pro from EcoFlow. Now, EcoFlow sells these units, but what Winnebago is using is not exactly an off-the-shelf unit. They've been working with the EcoFlow folks to kind of fine-tune this for their own needs. Now, it's kind of like a 5-in-1 device. Now, in our own 20K system, I used Victron equipment, but it performs kind of all the same functions. And so what I thought I'd do is kind of walk you through each of those functions, tell you how we do it with the Victron, and then how this is done with the EcoFlow. So we'll start off with the inverter. Okay, so here is our inverter in number 1. It is a Victron Multi-Plus 2. Now this can put out about 3,000 watts typically, which is perfectly fine for a coach this size. And it can peak at around 5,000 watts or so. But the EcoFlow Power Hub Pro can put out around 3,600 watts, and it has a peak, at least on the spec sheet, of somewhere north of 7,000 watts. Now, obviously, I haven't tested that, but that's what it says. So as far as inverter capacity, I'd have to give the nod to the EcoFlow because it does have a little bit better ratings. Now, this is also our battery charger. In charge mode, this can charge at about 120 amps, which is like 1,700 watts or so. That's pretty good. But the EcoFlow Power Hub Pro can charge at like 3,000 watts. It's almost twice as much. So again, I'm going to give the edge to the EcoFlow. And I think it's the 12 volt versus 48 volt architecture getting in the way there, because 120 amps, that's a pretty significant amount of amperage. But at 48 volts, it would only be 1/4 as much to beat that. So there we go. So that's the inverter and the charger. Okay, now the third component in the EcoFlow, that's scary. Third component in the EcoFlow Power Hub Pro is a DC to DC converter down. I'll call it down. So with a 48 volt battery, remember like all the lights in your RV, those are all still 12 volt appliances, your water pump, all that stuff, 12 volts. If you've got a 48 volt battery, you need some way to get that voltage from 48 volts down to 12 volts to run everything. So that's another component in the EcoFlow Power Hub. Our own RV, since we're a 12 volt system, I don't need that component. So I don't have one. I do have an awful lot of blue boxes here. We'll mention this later. So I don't have one. Now the one in the EcoFlow Power Hub Pro, that can handle like about 1,000 watts DC. And if you think about the things you're running on DC, your lights and water pump, that's more than you're ever likely to need. So the next component in the EcoFlow Power Hub is a DC to DC converter up for the chassis alternator. So let me explain. Look in here and try to imagine me cramming in another blue box about half the size of that. Okay, that's kind of what we're talking about. Again, we don't have one here, but what a lot of Echo owners do is they will install a DC to DC converter so that they can use surplus charging from the chassis alternator. In this case, that would be the Ford alternator or the Sprinter alternator. Use excess capacity from that to also help charge the battery. Well, your chassis, your vehicle's electrical system, still a 12 volt system. So to charge a 48 volt battery, you've got to get that 12 volts up to 48 volts. And the EcoFlow Power Hub Pro has a component that enables that. If I wanted to use that extra charging from the chassis alternator here, I would literally have to install another blue box somewhere. I don't have room for it, but I have to install another blue box in here somewhere to be able to connect the two systems so that I could charge the lithium batteries appropriately. So now, MPPT solar charge controller. The EcoFlow Power Hub, part of the PowerMax system, has two. I've got one here, and it's this guy. So again, imagine another box this big or bigger, right? But here's the thing. This one is one I installed. It can handle about 1,000 watts of solar panels as input. The ones in the EcoFlow can each handle 1,600 watts of solar panels as input, which is kind of a lot of solar, more than you're ever going to get on like an RV this size. But so imagine another box that size in here for a second MPPT solar charge controller. Okay, so that's sort of the individual components of the PowerMax architecture, but more than just the specs, which I'll just be honest, I'd have to look them up if I wanted to know them again, because I'm going to forget. But it's more than just the specs. I came away with kind of 4 kind of main observations or feelings about this. And the first of these has to do with just efficiency, even just in terms of like size and weight. Look at everything in here. And then remember, there's another fairly big box outside that's my inverter charger. And then remember, to do everything the EcoFlow unit does, I've got to put 2 more boxes in there. Think of all that and think of the savings in size and weight and space just by moving that all into a single unit. So that's a great savings. I mean, even just something as simple as like sharing cooling fans between components. You know, you can optimize where the cooling fans blow so that you can just reduce the size, weight, and complexity even further. The next is performance. So look at all the wiring in here. And then as you look at the wiring, remember that every place you've got wiring, that's some place where like you're going to lose, there's going to be losses, and it's going to be proportional to the amount of wiring you've got. And I've got a lot of cabling here. I've tried to minimize the losses by using big cables where I can, but by having everything all in one unit, nothing's got to move very far. There's no wires. There's probably some sort of internal bus bar architecture like what I've got there, but the performance is going to be improved by not having just all these wire runs. And then the third thing is fewer points of failure. Look at all the connections I will have made in here, and then just think, every one of those is a place where I could mess up or it could come loose over time, and then that's going to be extra resistance. It's going to be heating. It's going to be a potential source of failure. By having that all in one box controlled in a managed factory, the number of points of failure is greatly reduced. And I guess probably the last thing is just the convenience factor. So everything that EcoFlow unit does can be controlled from its control panel. Even something like turning off your 12-volt DC, like we've all had those like 12-volt coach battery cutoff switches that in an Echo don't really cut off anything except the fuse. In a PowerMax vehicle, you'll do that digitally on a control panel. If I even wanted to have a control panel for this, I would have to install yet a third extra box. Don't get me started on the servo. I'd have to install yet another extra box to have a control panel that I could control all this from. Now I can do it from an app, and there's an app with EcoFlow as well. But the convenience of having everything all in one is really not something to be understated. Now I'm making myself feel bad for all this messy wiring. And I really tried to keep it neat. All right, so let's put a bow on this thing. Winnebago's PowerMax architecture, what is it? Well, 48-volt architecture, so think faster charge rates, right? Batteries with an external BMS, so it's easy to change capacity, like just plug in more modules, that's pretty easy. External BMS, beefier, sturdier, single point of information for all your batteries. And then we've got that 5-in-1 EcoFlow Power Hub Pro. 5 functions, a whole lot of, if you want to think of the 20K system, think of a whole lot of blue boxes that we're replacing with one smallish box. So convenient, a lot of savings in size and weight, and a lot of efficiencies to be gained from doing that. That's kind of what you need to know in a nutshell. So I hope you found this helpful. If you have questions, I will try to get them answered. There'll be a link in the YouTube description down below. Just pop on over to the Fit RV, ask the questions, and I will try my best to get them answered for you. And I guess that's going to do it for now. This is James. See you later. Bye.